Hi, I'm an old guy and I do maths, and today we're looking at probability density functions and exactly what they are. So, a probability density function is a perfectly normal, everyday type of polynomial function, but what it does is it describes a probability, and it's the area under the curve of that polynomial that gives us the probability of an event. So let me see if I can illustrate this. So here's our function, a polynomial, and it's got a domain between 0 and x. And that domain between 0 and x limits the area under this curve to 1 at maximum. Because the probability of an event occurring cannot exceed 1. 1 is an absolute certainty, 0 means that it's not going to occur at all. And what we're interested in is we're interested in the probabilities between those. Now, so what's involved? Well, obviously we are going to be looking for the area under a curve. And so we're into definite integrals, and definite integrals are written in this form. We have a minimum value that we calculate, a maximum value that we calculate. Those just happen to be those at the moment. And we get antidifferential for the original function minus c. We do not use c. So if we wanted to know, let's just say that if that is x, this point here is a half x. If we wanted to know what the probability of an event was between 0 and half x, this is what we would do. We would integrate the function, whatever it was, and we would find the value of that function when we put a half x into it. So we would work out that value, and we would work out this value, 0 dx. And what we would do is we would subtract this from this. So what we do is we get a value for the area here. If I can just shade this in a little bit. And we get a value for the area here using 0. Now, this will usually come in at 0. It's I can't think of an occasion in which this will not come in at 0. But if we were working, say, to 1/4 of x, then this would become 1/4 of x, this would become 1/4 of x, and we would have discovered the area in here, and that would give us the probabilities of this event occurring between 1/4 x and 1/2 x, and that's essentially how this works. So the long and the short of this is that when you're dealing with probability density functions, you're simply discovering the area under a particular curve between one point on the x-axis and another. And so all it is the application of one of the features of definite integrals to probability, with the proviso that the area under the curve does not exceed 1. Okay, thank you for watching. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.